Okay. Um, Hello, everyone. Welcome to the last session of today for the Kicks track. Today, this session, we have Tom Slattery, which is working for the Kicks development team in customer in production, and talk about their modernization journey. So over to you, Tom.
Hi everyone, I'm Tom Slattery from the Kix Customer and Production team. I'm not sure how many people we've got, but I'm very happy for this to be quite an interactive session. If you want to jump in with any questions or send any questions to the Zoom chat, yeah, happy to discuss anything further from the session. But what I'm here to talk to you today about is to introduce you firstly to customer and production testing in Kix, what that means, what we've gone through in our journey of creating our team, how we're testing Kix, and also how we're evolving CIP testing in Kix. So taking you through our process. And I feel a good way to introduce what the CIP team is about. By the way, I am going to abbreviate customer and production as CIP. That's what I'm specifically talking about there. Um, what a good way to introduce what our team is about, I think, is to introduce some of the team members. So I've included a slide here that's got our team and our contact details as well. So I will be uploading the slides and you can access this if you want to interact with us. As a team, we really value customer interaction. So if you want to open any conversations with us, that's very important to our message as a team. So we created the CIP team to try and cover a breadth of different topics in Kix application development. So we've got members of the team who have got experience with application development on Z, so that kind of COBOL, JCL skill set. But we've also tried to cover lots of skills, including application development, system programming, and DevOps engineering in particular as a developing theme. So the creation of things like CI/CD pipelines is particularly what I'm involved in the CIP team. Now, as a team, we have a quite clear mission statement, which is to act as the first customers of Kix. So a customer-centric approach to testing. We have a production environment that we run as closely as we can to a customer environment. We develop a Kix application modeled on the kinds of things customers of IBM create. And our real goal is to ensure that we can develop that application. We encounter all of the different kind of scenarios that customers might in using Kix. And a really important theme is just that last clause of our mission statement there, ensuring that both continue to function. One of the most important things that we want to do is ensure that as Kix rolls out updates, we don't see any disruption to our test environment, because that would be the last thing that we would want, is for customers of IBM to have disruption to their production environments from upgrades to Kix. So just to reiterate, our goal is to act as customers, follow a customer-centric approach to testing, evolve our banking application to represent customer requirements of Kix, and ensure that Kix continues to function in our environment. So I'm going to talk a little bit about where CIP testing came from in Kix. So Kix testing grew to become more agile. We adopted agile development for testing in the Kix department. And we were finding that there were some scenarios that were a little bit missed by systems testing. So really more complex integration testing types of scenarios. So we were feeling that there were areas that just couldn't quite be covered with testing at that scale. So we wanted to find a way of stepping back even further from the product and testing at a higher level. So to achieve this, we wanted to design the subject of test. So we wanted to design an actual Kix application which would represent customer environments. And from that was born the Bank of Hursley Park application, which is named after the Hursley Labs where we work. So the the three key themes here that I wanted to identify for this slide were testing as a customer. So testing Kix from the perspective of using it, like actual customers of IBM. So not just on the level of checking that our bank works, but actually running things like workloads through our banking application, operating it like like people who are using a customer application would. So this allows us to capture defects that would actually really impact customer environments. We have a secondary goal in CIP, which is actually sharing our experience and opening a dialogue with customers of IBM. So we work with both Kix development and with customers of IBM through outreach. So as a result, we're able to really provide insight on our experience of using Kix. And also, we want to encounter all of the same challenges that customers experience. And ideally, we want to encounter them first so that we can provide a roadmap to help provide technical guidance to travel through them. And a particular area that I've highlighted there, compliance, security, and system upgrade, especially system upgrade. We run our production system constantly and we roll out upgrades to it. I've got more on that in a slide coming up. So I wanted to give just a quick overview of what the Bank of Pursley Park application actually looks like. This is what we have ended up with as our design, but this is constantly evolving. And what we wanted to do in the design for this application was we wanted to create something that was scalable and customizable. We didn't just want to represent one specific use case of Kix, but we ideally wanted something that we could deploy to be many different shapes and sizes to represent a wide range of customer environments. So the Bank of Pursley Park has got two main interfaces. We have got a 3270 terminal interface, which can talk via VTAM to terminal owning regions. And we also have a React app, a front-end web user interface, which can be used to interface directly with the bank. And we designed that to run on Liberty owning regions, running WebSphere Liberty. Now, the way that we've structured the Kixplex for this application is for the regions to be customizable and to have any number of regions that we like to communicate with each other. So I've tried to represent a number of terminal owning regions talking to a number of application owning regions. Now, for data stores, we've got different options for the bank. We can use DB2 as a data store, or we can communicate via file owning regions to vSAM data stores. We've also got support for IMS, and we can also communicate to other instances of the Bank of Pursley Park application or other services across sysplexes via MQ. Now, this represents particularly customer ways of interacting with the bank here. So you can imagine a bank teller persona might log on to the bank application through the 3270 interface, or perhaps through a more modern interface like the React app to perform their daily tasks. But we also wanted to capture the kinds of interfaces that a systems programmer would use to control the banking application. So we've also got the Kix web UI, which provides a means for a system administrator to interact with the system via the CMAS. And that can also be connected to a systems administrator console running in the Explorer, so an Eclipse-based UI. So that covers the architecture of the bank. We ideally wanted here to create something highly customizable, so with a wide range of different ways in which it can be deployed. So that brings us to a bit of CIP history, a bit about our journey to arriving at this conclusion. Because what I've started with here is really the state of art of CIP. So what I want to walk you through is how we reached there and what our plans are for growth of the project. So CIP was founded in 2016, and we started with an understanding phase. We really realized that one of the most important aspects of this project was realism to customer environments. So we started with a long information gathering phase. From that, we began the development of the application, and we made sure that this was an iterative process where we tried to keep up with customer feedback and adjust our design. And now currently we're in the growth phase for the project where we try and understand current industry challenges and adapt the project to match. So digging a little deeper on the phases here, we started with an information gathering phase, and we started with a lot of surveys and customer interviews. A fair number of the CIP team have got a lot of previous industry experience. So a lot of the knowledge which started the CIP project came from working at customers of IBM. And we also have a final data source that we can use, which is which we can layer on top of that, which is the information contained in APARs. So whenever any problems are raised by customers against Kix, we can also see that information and we can use it to inform the design process for the bank. Now, we started this project with an appreciation that we're trying to represent a lot of different customer environments, and really, banks are not the only customers for Kix. There's also insurance companies, customer data storage, that kind of thing. So while we wanted to be true to customer environments, we didn't want to be fully faithful to any one particular use case and to block off the chance to be relevant to other customers. So we wanted to amalgamate this customer feedback and create a design that represented as much as possible, or at least was configurable to represent as much as possible. And finally, every member of the CIP team has a few customer advocacies, and we try and use this as an opportunity to stay up to date with what customers are currently doing and the challenges that customers are currently facing in the industry. A little bit more on that later. So that brings us to the development phase of the project. Again, I want to stress this has been an agile process, so these phases really do overlap, and we have been adjusting our development as we go. But we wanted to develop this application. We set a goal of developing the initial design for Hersley Bank, and this was quite a large investment for Kix. We had to take several developers away from Kix development and Kix test development to work on this project. And really, this was a new venture for the Kix department. This was a completely new way of testing to us. So we wanted to ensure that we were delivering value for this endeavor. And we wanted to make sure that the Bank of Hersley Park was a long-lived asset. We didn't want to create a single sample application for Kix that was scoped to one use case. We wanted this to be a project that was long-lived, constantly updated, and could be used for a wide range of different demo scenarios. We also had a secondary goal of this being really a tool for education. So the Bank of Hersley Park provides a kind of common environment that we can use to recreate customer scenarios and share information with customers of IBM. We find this is a really useful way to just have an immediate, familiar looking Kix application. So when demonstrating something for customers, we can just bring up an instance of the Bank of Hersley Park to really show a feature in action. I want to just hone in on two particular case studies of value delivery from the CIP team. So firstly, upgrade testing. Now, this was really a scenario that wasn't possible to capture using integration or system testing. So we were finding in the running of our production system that there were several quite major assumptions made by the documentation about the nature of customer environments. And some of those assumptions were not actually necessarily realistic to customer environments. For example, things like shutting down Kix resources to apply an upgrade and then bringing them back up. We understood from our research phase that really customers tried to avoid completely destroying Kix resources and bringing them back up again if possible. And we were finding that in applying upgrades to our production system, we were encountering scenarios that just did not seem realistic for customers. So we provided feedback back to the documentation team, and that was adapted to become a more nuanced process that is more relevant to customer experience. And as a secondary outcome for that, we realized that there was a value in maintaining a constantly available production environment that we just keep running all the time and rolling out upgrades across it to test that the current documentation is valid and that it's possible to upgrade Kix without an interruption to the service of the application. A second example here that I want to highlight is deployment migration. So prior to what we were doing in CIP, when we first started with developing this application, we were using quite homegrown solutions for application deployment. So we were finding that there was actually, while the application was relevant to customer experience, some of the actions that we were taking in our development process for the application actually diverged from what customers were doing. So we were finding that there were actually areas in application deployment, continuous integration, that kind of thing that were different to what we were doing, making it a little harder to relate for customers. So what we really wanted to do there was to migrate to IBM recommended tooling. And at the time, that was using IBM Urban Code Deploy for the deployment of the Kix application. And we really didn't want this to be a sort of proof of concept that we just demonstrate is possible. We actually wanted to make this the center of the deployment automation for our team to really fully demonstrate that agile and automated deployment can form a part of the team's development process. And we found by doing this, we were better able to relate to the development experience of customers, but also to provide guidance on migrating to an automated build process. That brings us to the current phase that we're in now in CIP. So we're currently in our growth phase. And the real main points for us at the moment, our main goals, is remaining aligned with the industry trends. So we want to keep up to date with the current practices that are being adopted by customers of IBM, but also to provide guidance on our own experience of adopting these practices. We want to really continue to encounter those kinds of customer pain points. We really want to experience all of the different kinds of problems that customers may run into ahead of customers so that we have an awareness of that and we can feed it back to the Kix development team. And again, that's another reason why in CIP it's really important to us to engage with customers, such as events like GSE or Share, because it's really an opportunity for us to check our alignment with what you're currently doing. And from this, we can target areas for improvement. So we can remain reactive to industry challenges. We can integrate customer feedback into guiding our team in the next directions that we take. And I've got a couple of different customer engagements that we have a presence at. So the Kix Design Partnership, Kix Architecture Forum, Share, GSE. These are all opportunities to come and talk to us. Now, as a result of the growth that we've done so far and our understanding of what the challenges are that customers are currently facing, we've decided to undergo a transformation in the customer and production team. So this really crystallizes into two particular sections that we're undergoing a transformation in, modularization and modernization. So modularization is an undertaking that we're doing at the moment for our code base of the Bank of Hursley Park application. The way we developed the Bank of Hursley Park was to create several large components of the application. And these became fairly monolithic. And this was really an area in our initial design that the development of a realistic customer-like application came into a little bit of friction with the goal of developing a general representation of customer applications. Because we ended up with so much configurability in the application, we were finding that the application became very large, perhaps unrealistically large compared to the customer applications we were trying to represent. So our current goal is to create much more tightly self-contained modules for the code base. So breaking it down into what could even be referred to as a sort of microservices style approach to application development. We really want to split up the code base into modules which are optional, and we can use to build up the application, build up a configurable application. Now, this as an objective for CIP is something which we want to undergo in a customer-like fashion. So one of our goals for the modularization of the Hursley Bank application is to ensure that we can perform this task without breaking the application and without affecting the production environment. Now, there are three goals in doing this, particularly demonstration. We really want to lay out a pathway for how this kind of modularization of a large Kix application can be planned and be undergone by a team. As we've observed that this is a modernization trend that customers want to undergo. Now, as a benefit from this, we get better integration. So the modules that we're creating can more easily integrate with each other or integrate with other modules that we may add later. So we get the ability to make a more configurable application that is actually easier to develop additional features for. This will keep the development pace of CIP fast and also help us to remain reactive to industry trends. We also, by modularizing the code base, aim to adopt a sort of shift left testing approach in the team. So by discretizing these components, we actually are able to test them individually. And as you'll see from the next slide, automated testing is a major theme that we're trying to embrace in CIP. So that is the modularization of the code base side of our transformation. Now, the next slide is our DevOps modernization, and this is the part of the project that I've been particularly involved in. I should also say up front, I have a session tomorrow at 10:30 where I'm showing demos of pretty much all of the automation that I'm referring to here if you want to see it in action. So we have created this application so far, and we've undergone a development process, but we actually want to ensure that it's not just the application that's true to customer activities. We really want our design process and our process of development to also resemble the current state of the art for development of Kix applications. Now, to do that, we're transforming the way that we develop and deploy the Bank of Hursley Park application and the way code moves through the project. So I've been working on creating automated pipelines for continuous integration and delivery of code in the CIP team. Now, we've got three objectives for this. So code promotion. I want to introduce a process for moving code through the team. So through from a local development environment all the way up to our production system. And I ideally want this to contain all of the checks that we would want code to go through to ensure that it won't affect the production environment. And in doing this, I'm going to be pulling in all kinds of technology from the different departments in Kix at the moment into one unified pipeline. So uh, that involves deployment of Kix regions using current technologies like Ansible. If you're at the DevSecOps presentation today, I will be involving DevSecOps in this pipeline as well. So scanning using SDV, all of that. So we ideally want to ensure that code going into our production system is tested to the level that a customer would be happy for it to go into their production system. Now, as a part of this, I'm introducing automated testing here. So we really want to adopt automated testing, and we also want this to be adopted using this shift left methodology, where we have got tests which happen as early as possible in the automation and fail early. So that might sound like a negative thing, fail early, but actually, really the goal is fast detection of problems. So when you put it that way, when you're delivering code, you want to know that the code is not up to the standard to go into the production system as early in the pipeline as possible. That way you can fix it quickly and it stops it getting into higher levels of development where it would be harder to undo and harder to rectify. To do this, we are adopting the Galassa test framework. So you may have been at some talks to do with Galassa so far, but that is an open source testing framework that was originally born as an inner source tool in IBM Kix. But we realized that as a mainframe testing tool, it would be useful as something which could be contributed to by and used by any customers of IBM. So our adoption of Galassa is also something that we want to show as a suggestion for integration testing on the mainframe. And to add to this, we also want to introduce automated code scanning. So this is a little bit of the DevSecOps approach here. So we want to ensure that we remain compliant and we want to include scanning in our pipeline. So we don't, ideally, we just want to do away with manual tasks. We want all of this to be tasks which are automated but are controlled by the developers. So feedback going back to the developers in CIP. So what I want to do for this section is I just want to go through the modernization that we want to do on our build process. And what I'm going to start by doing is just go through the build process as it was when I joined, and then I'll show you the transition that we're currently going through to build a modernized development process. So this was our first build pipeline really in CIP. Now, the way this pipeline worked was really it was a large step up for us because it automated a lot of tasks that we were doing manually initially. But itself as a pipeline, it still contains quite a few tasks that needed to be done manually by the developers. So I like to view this as like the kind of beginnings of a continuous DevOps pipeline, but each of these steps individually are really a DevOps process. So in the CIP team, we originally started by using a rational team concepts to as our source code management. So that's where our code lived that we developed. And most of the tasks which happen in this pipeline are triggered manually by the developer after they have committed code to this to the source code management. Now I've got to remember my RTC terms now. I think that's a change set rather than a commit. I should be saying there. So on delivering a change set of code for the Bank of Hersley Park application, a developer would trigger a build that would build the code that is sitting in RTC. So This would be an ant-z build process that would produce some build artifacts on a Z mainframe. We would then use IBM Urban Code Deploy to take those artifacts that have been built and deploy a Kixplex to that mainframe, and then install the code that had been built onto the Kix regions, producing a developer-managed Kixplex running the Bank of Hersley Park application. So those were two manual processes resulting in a test environment. Now, at that point, we've got a test environment, but it's up to the developer to now verify that it meets the standards that they desire for the application. So that would have involved running manual tests initially. So the developer would run through all of the screens of the Bank of Hersley Park application, check that the things that they wanted to work still worked. We also had some automated tests using the JAP framework, which is an IBM internal, Kix internal tool. And we also had the option of running some longer running TPNS production environment workloads, depending on the intention of the environment as it was deployed by the CIP tester. Now, once the testing has been completed to the satisfaction of the developer, the code would then be promoted to the best so far stream in RTC. Again, that's analogous to a branch in GitHub. And finally, the developer would be responsible for manually cleaning up their test environment by running another Urban Code deploy process. So I'm hoping from my description of this pipeline, you can see how this would speed up a lot of the processes of installing an application, setting up an application, testing that we were originally doing in the CIP team. But there are a few keywords which are popping out as perhaps anti-patterns or things that could be improved by a more modernized design. So particularly, there are still manual steps in this. So um, manual step of initializing the pipeline, starting the ANSI build, and then a manual step of starting the Urban Code deploy processes. And this was actually made a little worse by the fact that some of these processes took quite a long time to complete. So the build process for the ANSI build would take a few minutes, and then we would have three IBM Urban Code processes that would take a few minutes each that we would have to come back from and trigger the next one. So a few areas where developer time was being spent waiting. And then also a really key word there was to the satisfaction of the developer when I was talking about manual tests. So really there was no hard quality gate on the code being promoted other than whether or not it met the satisfaction of the developer. And as you know, developers are humans, are fallible, and we all make mistakes and miss things at some point. So really we didn't have any actual hard quality gates on the code being promoted through our development levels. And as a final point, one of the things I mentioned there was a developer managed test environment. So the Bank of Hersley Park application that was stood up by Urban Code belonged to a single developer. It was created under their user ID and it had data sets which were created for that developer. And they would be responsible for removing it. If they didn't remove it, the next build would fail to deploy their next test environment. And I constantly forgot to do this. Again, on developers being fallible, this would be a real problem that you would have to manage an asset that was initialized for you by an automated process. So those are three really key areas that I wanted to address with a modernized design for the CIP build process. So what I have here is the transformed build process for the CIP CI/CD pipeline. So firstly, you may notice a transition of technology here that's happened. We actually moved away from using RTC in the team to move to GitHub. And this was reflecting an industry trend that we observed, but also a movement within the entire Kix department. So all of Kix has now moved to using GitHub. I wanted to design this pipeline with a different model to the last one. I didn't want this to be a pipeline which was manually triggered by a developer. I push my code and oh, I remember I've got to go and start the pipeline. What I wanted here was an event-driven pipeline. So the pipeline is triggered by developers completing actions that they want. So a developer has a goal of promoting code from their local machine into the production environment. So by performing the actions that they would already need to do to complete that, so for example, opening a pull request, I wanted that to be the trigger for the pipeline rather than it being an end in itself. I decided to achieve this by using Tecton, which is the IBM currently recommended tool for automation. Now, I initially did use Jenkins to do this, and I think probably Jenkins might be a more familiar platform for most people doing automation at the moment. And I'd like to just, if you've got Jenkins experience, you'll probably know this is something that's possible to do with Jenkins. It's not just a Tecton unique thing, having an event listener on a GitHub repo. But I did decide to use Tecton just for its modularity of tasks and the fact that I can create Tecton tasks for running specific tools. I found that I had a Jenkins agent full of different tools, and I wanted to modularize that into separate tasks. So that's what led me to decide to use Tecton for this project. Now, in this pipeline, I set a goal of sort of exercising some of the latest technology that IBM are recommending for deployment. And I wanted to do this, I wanted to particularly use Ansible in this project, as we have got offerings in the IBM z/OS core and z/OS Kix space at the moment. So we've created, the Ansible team in Kix has created some collections for Ansible. If you're not familiar with Ansible, it is a means of running automation on managed nodes. And I decided to combine this with Tecton. So Tecton acts as the high-level CI/CD orchestrator, and then Ansible acts as my means of managing tasks on z/OS. I thought this worked as a model. So Ansible for deployment, Tecton for the running of the entire pipeline. So I'm currently working on creating provisioning for a Kixplex on a system. What I currently have is Ansible playbooks that will provision a single Kix region. And I will create playbooks that compile and install the Bank of Hersley Park application onto the Kix regions in the Kixplex, creating a test environment that is managed by the pipeline. So what I wanted to go for here is an isolated development environment for testing in, rather than something which the developer has to remember to look after. Now, instead of manual testing, instead of operating the application by hand, this is where I employ Galassa, and Galassa is running from the Tecton pipeline, running a set of integration tests against the application. And Galassa is quite nuanced in the way that it can interact with a Kix application. You have the ability to do things like operating a terminal, but on top of that, you can also use things like the WebDriver to operate the web user interface to Hersley Bank. So lots of options for really deep integration testing there. Now, a really important key for this event-driven model is I did not want this to be a pipeline run that was sort of managed by the developer. Again, I wanted the developer to just do what they want to do in development and receive results to the interface with which they triggered the pipeline run. So what I've developed is a way for the Tecton pipeline to report information back to the GitHub checks user interface, which appears on the GitHub pull request. So the developer can receive quality gate information about whether the code that they're committing meets the standards that we want directly to the UI that they use to request the merge of the code. So they don't need to go over to Tecton. They don't need to look at the Tecton dashboards. They don't need to do that kind of thing. They just see directly on the UI they requested this with, what the result of the check is. Now, if you were at Mark Lawrence's SDV demo, he's beaten me to it in showing how cool GitHub checks are. So he's done a demo using GitHub checks there to report information back. I have something similar for my pipeline demo tomorrow. A final aspect of this pipeline as well that was really important is to manage the life cycle of resources created by the pipeline. Um, so what this means for this pipeline is I wanted to use the object that created the pipeline run, the GitHub pull request, as the way of signaling how long a developer wants a resource to be persistent for. So the developer having the PR open is a good indication that they want their test environment to remain up. But closing the PR is a good indication that they have finished all the testing they need to do with that particular bit of code, and the environment can be cleaned up and removed. This means that the developer is no longer individually responsible for their own test environment. They don't have to manage it themselves. It just goes, and there's no chance of it colliding with other test environments. So ideally, just sandboxed, short-lived test environments. So that was a lot of pipeline design information there, and I just wanted to highlight from that a few key points of our technology journey. So just to try and sort of distill out of that the movement that we've gone through in terms of DevOps platform, source code management, that kind of technology. So specifically for source code management, we performed a migration from RTC to GitHub Enterprise. Just another reason I want to highlight that is that every migration that we perform, we learn from. So if any customers are planning on performing a migration, and you want someone with experience of doing something similar, you can talk to us. We have experience of doing some things like this. Now, for our build technologies, I've changed what we're using for our build process. So we've evolved from using IBM Urban Code Deploy to using Tekton as a CI/CD framework, Kubernetes as the underlying runner for the Tekton pipeline, Ansible for handling deployment of Kix applications and compilation and install. So really managing anything on ZOS is done via Ansible. And to enable Ansible to do this, I've been using the IBM ZOS Core and ZOS Kix provisioning collections, which are publicly available on the Ansible Galaxy collections. So those are available for you to install and use now. In testing as well, we have also transitioned from both manual testing and a homegrown inner source testing framework to using Galassa, which has now been accepted as part of the Open Mainframe project. So we have got a suite of tests for the Bank of Hursley Park application. We've got an automated test running agent, which is the Galassa ecosystem, so a server on which to run our tests in automation, as well as run locally. And if you use Galassa to test your mainframe applications, we will have a common testing framework. So any kinds of questions about how to do integration testing on the mainframe, we could share a testing framework there. So we've got experience to share on that topic. Now, I want to introduce CBSA at this point. This is one of the last key points from our technology transformation and CIP. So CBSA is Kix Bank sample application, and what we really wanted to do here is we wanted to distill everything that we learnt in developing the Bank of Hursley Park application into a really easily consumable Kix application that would be easy to deploy for demonstration purposes. And we decided the best way of making this making this into a platform that's available for customers of IBM is to open source it. So CBSA is an open source Kix application written by the Bank of Hursley Park that represents the development that we did for for the Bank of Hursley Park application. So originally this was born from the requirement from tech sellers to have a Kix application to demonstrate with. So we thought that it would be really good to have an application that would be maintained constantly. So rather than having lots of disparate Kix demo applications that maybe have a longevity scoped to just a single demo, we thought what would be really good is a general Kix demo application that covers lots of bases and can be adapted to different scenarios, but crucially is kept up to date by the development work that we're doing on the Bank of Hursley Park. So CBSA is a hybrid terminal Liberty Spring Boot z/OS Connect application with configurable data stores. So the important thing here, those data stores being DB2 and vSAN, the important thing there is not all of that is needed for CBSA, but it's options that you have for a CBSA deployment. So rather than having all of the complexity of setting up the Bank of Hursley Park application, you can select features that you need to cover the demo scenario that you want. I've already used this application for several customer demos, including demonstrations on Resource Builder and of the for tomorrow's demo in of the DevOps technology that we're working with. So this is a tool for really kind of communicating information with customers. So yeah, our hope with CBSA is to release it as a project, for it to grow, for it to be accepted into the open source community. So becoming a means of sort of sharing contributions between customers of IBM and the CIP team. Right. I think having talked about CBSA, if I've got a few minutes left, yeah, I do. I think I might break into a demo just because I can't resist doing a demo. So if I come out of my slides, I'm just going to jump into a host on demand session and just show you what CBSA actually looks like. So I have a pre-prepared Kix region called Share CBSA, which I can log on to. That's proving to be a very slow terminal. I wonder if that's gone to sleep. Let me open a new one. Yes, I caught host on demand off guard there by using it suddenly. So what I can do is I can open the online main menu and I can give you a quick tour of what CBSA looks like. So CBSA is modeled on a banking application. It doesn't have the full feature set that the Bank of Hursley Park application does, but it's fairly comprehensive. So we have the option to look at customer data. So we have a large number of customer records generated to a vSAN data store, each with procedurally generated random names and addresses. And we also have account information, which is stored in DB2, just demonstrating the fact that this application can talk to multiple different data stores. We also have a few extra kind of banking style features like transferring funds around. And as a fun example, I can look at a particular customer number and I can find the accounts that belong to that customer. So just as an example of the 3270 terminal interface, we also have a React app front end, which really is just a web UI version of this interface. So a more kind of updated version, more updated looking UI that might be more reminiscent to the kind of banking UI used by bank teller today. Okay, so that's a quick tour of CBSA. I'm just going to jump back to my slides. So just want to finish up by laying out the roadmap for our next steps of this project. As you'll recall, we're in the growth phase of the project, so we're really wanting to lay out goals that continue to keep us aligned with the development done by customers of IBM. So we have completed the development of a front-end React app UI for CBSA, making it a more relevant and modernized demo. We have released CBSA publicly. So on the KixDev, I encourage you to go to the KixDev GitHub, github.com repo, and that contains the CBSA code, which you can look through and deploy yourself. We have deployment installation instructions. I have a link on the last slide of this presentation that you can go to if you want to directly go to that repo. Now, our near future goals are to complete the modularization of our code base. So componentizing the Bank of Hursley Park code, pluggable integration with the different tooling that we're using. We also are modernizing our code base as well. So improving our processes, our DevOps process, and our automation. So introducing code scanning like static code analysis and shift left testing. And finally, the modernization of our DevOps processes. Something that I would add to that is that in addition to the pipelines that you've seen for the Bank of Hursley Park application that I've been working on, I've also created pipelines for CBSA, so for the deployment of CBSA, and I plan for these to become open sourced as well. So a demonstration of how you can create a CI/CD piece of CI/CD infrastructure for a Kix application. So yes, last points. Can we have some help? Any interaction with customers is really useful for us. So we have a form here. So for any feedback that you have on the project, any insight that you can give us, that would be really useful. And session feedback. We're session 3L here, so if you could provide any feedback on the session at all, that would be really useful. And for a more hands-on technology demo of this pipeline, I'm going to show a demo of the CBSA pipeline tomorrow. So yeah, I think that's everything. Are there any questions on any of that?
Thank you, Tom. I haven't seen any question posted yet. So yeah, if you have any question, please feel free to post or ask any host to unmute you. Do you know the time and the session for your tomorrow's one, which was
Yes, that
demo?
that is 10:30 tomorrow, and I believe it is 2N.
Thank you.
Let me just check that to be sure, because I don't want to send people to the wrong session.
It's 102 stream,
Yes, 2N. That's right. Yep.
10:30
Yes.
UK time.
UK time. Yes.
Thank you.
British summertime.
Oh, yes.
Yes.
Thank you. Very, very detailed presentation.
Thank you.
Okay. So there looks like there is no any questions being asked. Okay, good. So thank you all for joining the last session for today, and hope to see you tomorrow in Kick's track. There are 4 sessions tomorrow. Then I'll say goodbye and see you tomorrow. Thank you very
Great.
much, Tom.
Thank you all.
Thank you.